So first of all, the last time I had a conference, somebody asked about this question. I went back and I looked at it and I realized this is just a conversion. I don't know what I was thinking before. But this, the 4.02 times 10 to the 23rd molecules, how many moles is that? You just have to convert it into moles using Avogadro's number. So 1 mole is equal to 6.02 times 10 to the 23rd. I think I read it and I thought it was something different. But I was thinking maybe I could do one of these problems first, and then I know there was a question in the packet that looks like this. And it's talking about TNT exploding. So there's like a small trick to this one. Okay, so unless anybody has anything else that they want me to go over, I was thinking about doing this. Is that good with people, or is there something else? Okay. All right, so if you guys come up with any other things that you want me to talk about, you can just put it in the chat and then I'll address it when I can. Okay, so with this problem right here, the first thing you have to do is you're going to have to balance this reaction, and then it's asking what volume of Cl2 will be needed to make 75 grams of the C2H2Cl4 at 24 degrees Celsius, and it gives a pressure. So, let's see. Okay, first thing, you're going to balance the equation. All you have to do for this is just put a 2 in the front, and that should be balanced after that. Yeah. So, first thing I do, and I still do this, I've been doing this for 13 years, but I will still go through and actually pull out all the information. So, the first thing, it's asking for a volume of Cl2. So, I'm going to write that down. Still do it after 13 years. Okay, so after 13 years of teaching, plus college and everything. So we have a volume of Cl2, that's what we're looking for. Will be needed to make 75 grams. So we have an amount, but this is of the product, the C2H2Cl4. Okay, so it gives us an amount, but it's for a different substance. Okay, so right off the bat, I can see that stoichiometry has to be involved here because I'm looking for one substance, I'm given information about a completely different substance. So it has to involve stoichiometry to some extent. All right, so we have a temperature. It's 24 degrees Celsius. All right, and then we also have a pressure. The pressure's in millimeters mercury. It's 773 millimeters of mercury. So when I'm looking at this particular problem, anytime you start to see, okay, I have a pressure, I have a temperature, and it's looking for a volume, you know that PV equals nRT will be involved with that. When you start to see those variables, you should already have that in your head. Like, I know I'm going to be using the ideal gas law. Okay. I also know that I'm going to be using stoichiometry here because it's looking for one substance and it gives me information about a completely different substance. So when I'm looking at this and I'm trying to decide which one am I going to do first, am I going to do Stoich first or am I going to do the ideal gas law first? Well, if you look at this right here, this is a liquid. You cannot put a liquid into the ideal gas law. So we're going to have to convert this into Cl2 first. Then we can solve for the volume. I do have a pressure, I have a temperature, I know R. If I know the amount of Cl2, I can solve for the volume of Cl2 here. So my pressure is in millimeters mercury. I am going to have to convert that, but first thing, we have to do stoichiometry first. So if I want to use N and plug it into here, it has to be for the Cl2. It has to be gas. So that's what we're going to do first. I have 75 grams of the C2H2Cl4. Okay, convert that into moles. So we know that 1 mole is equal to 166 grams. That's the molar mass. 1 mole is equal to that. All right, so anytime I want to go to a different substance, I'm going to have to convert it into moles. So whenever you have stoichiometry, you go from the unit you have to moles of what you have, then you go to moles of what you want. So we want Cl2, so we're going to go to moles of Cl2. Moles of what we have is on the bottom. All right, so moles on top of moles, we're going to pull the coefficients. There's 1 mole of that for every 2 moles of this. So when I solve for this, I'm going to get 0.451 moles of Cl2. Okay, so now that I have my moles, I can use my ideal gas law and find the volume. So my pressure, well, everything's going to match the gas law constant. So we know that R is 0.0821 liters, atmospheres, moles, and Kelvin. All right, so let's convert this to atmospheres first. Okay, so 1 mole is equal to 700, or not 1 mole, atmosphere, I'm sorry. Atmospheres on top because that's what we want. Millimeters of mercury on the bottom because that's what we have. 1 atmosphere is equal to 760 millimeters of mercury. That's going to give me 1.02 atmospheres. Now this also has to be in Kelvin, so add 273 to that. So that's going to give me 297. So I have that, I have that, I have my moles, so now I can just plug everything into the ideal gas law. So my pressure is 1.02, volume is unknown, my number of moles is 0.451, the ideal gas law constant is this, and my temperature is 297. Okay, so multiply everything out and then divide by 1.02. The volume should give you, the volume that you should get is 21.6 liters. And that's for Cl2. Okay. So I'm going to do a harder one. Let's do the one with TNT. Can I erase this? Okay, so this one is in the packet. I'm recording it right now. So yeah, I'll record it and then post it just like I've posted the other two. Okay, so I have an explosion. So I'm using TNT here, trinitrotoluene, and it makes carbon dioxide, it makes hydrogen, nitrogen, and then carbon. So essentially anytime you have an explosion, you have a lot of heat being produced at the same time you have a lot of gas being produced. So that causes pressure and then that causes the explosion. So we're going to calculate the volume of total gas produced in liters when you have 500 grams of TNT and it explodes at this pressure and 35 degrees Celsius. So still, first thing, pull out all your variables. So I'm looking for the volume, total volume. So I'm looking for, okay, I am looking for the total volume. So of all the gases that we produce, I want to know what is the total volume that they all take up all together. So I need to pull out my variables. When 500 grams, so I have an amount, but this is for the TNT. That's the TNT right here. Okay, that's 500 grams. And it explodes at a pressure 1.05 and a temperature of 35 degrees Celsius. All right, so you have an amount of TNT, and then you're looking for the total volume of all three of these gases. So you know that you have to have some form of stoichiometry here because you're given an amount of something. You're asked to go to something else. And if you're looking at the ideal gas law, you cannot plug in this because it's a solid. So you're going to have to convert it first, and then we can get the total volume. So we're going to do stoichiometry first. So essentially the rule is, if you're given a mass first, you're going to use stoichiometry first. If you're given a volume first, you're going to use the ideal gas law first. Or if you're given the volume, you're going to use the ideal gas law before you use stoichiometry. So let's go ahead and convert this. So the thing is, it's asking for all of the gases. So this, and this. So if you wanted to, you could do this one of two different ways. You could convert the 500 grams to see, okay, how many moles of this will I make? How many moles of that will I make? And then how many moles of that will I make? Okay, you could easily do that. You could do 3 problems first. Or you could say, well, I'm going to make 12 moles of this, 5 moles of this, and 3 moles of this. Altogether, I make 20 moles of gas for every 2 moles of TNT that explode. So you could do 3 equations, or you say that the ratio of gases to my reactant would be 20 to 2. So it just kind of saves us some additional work. So we're going to go from our starting amount, which is 500 grams of my TNT. Okay, still have to go to moles. Anytime you're going from one substance to a different substance, you have to go to moles. So the first step, get moles of what you have. Okay, 1 mole of TNT has a mass of 227. So that's the mass of 7 carbons, 5 hydrogens, 3 nitrogens, and 6 oxygens. So now I'm in moles of what I have. I can go to moles of what I want. Okay. So, because we're talking about all the gases, it's actually going to be 12 plus 5 plus 3, so 20 moles. There's 20 moles of gas that are produced for every 2 moles of TNT that you have. All right, so then you're going to go through that. You're going to get 22.02 moles of gas. So if you wanted to, you could do the same calculation. You could have gone to carbon dioxide first, then you could have gone to hydrogen. So you do separate problems. You could have done, okay, how many moles of carbon dioxide do I produce? How many moles of hydrogen do I produce? And then how many moles of nitrogen do I produce? And then add all 3 of them together. But I just saved a little bit of work here. So now I've got my moles. So I've got that. I'm looking for the volume, the total moles, looking for the total volume. I have a pressure, I have a temperature, I'm ready to go. So this is actually going to be 308 Kelvin. Remember, everything has to match the ideal gas law constant. So we have liters, atmospheres, moles, and Kelvin. All right, so go ahead and plug everything in. So pressure is this. Volume is what we're looking for. The total number of moles would be the 22.02. And then you multiply that by your temperature of 308. Okay, so when you solve, multiply everything together, divide both sides by 1.05. Your volume is going to be 550 liters. That's your total volume here. Okay, so do you guys think you're good with that? Do you have any questions on that one? Yeah, sorry, I asked two contradictory questions in a row. Sorry. Okay, cool. Just remember when you have these types of problems, okay, if you're given a mass first, or a mass, and you're looking for a volume, you're going to do Stoich first. If you're given the volume and you're looking for the mass, you're going to do the ideal gas law first, and then use stoichiometry. Okay. Now, let's erase that. Okay, so these types of problems right here. So when we talk about density and molar mass, a lot of these things, these concepts can be mixed in with ideal gas law problems. So, yep, that's exactly what we're going to do. We're going to find we're going to find density. We're also going to find molar mass. So, okay, when we talk about density, okay, so density is equal to mass over volume. Okay, so a density is really just a mass to volume ratio. So if I were to say my density is 1 gram per milliliter, what that tells me is that for every 1 gram, I have 1 milliliter. Okay, same thing for molar mass. A molar mass is a gram to mole ratio. So if my molar mass is 40 grams per mole, there's 40 grams for every 1 mole. Okay, so let's do the density problem first. So first thing I do, I'm going to pull out all the information first, because even after this many years, I still do that. So it tells us that the pressure, so it's at STP. So STP means the pressure. It's going to be 1 atmosphere. And I know my temperature, standard temperature is 273 Kelvin. And I'm looking for density. So in order to have density, I need 2 numbers. I need the mass, and I also need the volume. Okay, those things were not given to me, but I do know something else. I do know something else, that it's CO2. Well, CO2 has a molar mass of 44. So molar mass is 44 grams per mole. So I know what this means is that if I go weigh 44 grams of carbon dioxide, I have 1 mole. I know that that's a true statement. So if I have 1 mole of a substance, or of this particular substance, I have 44 grams. So what I could do, because I know this is a true statement, I could say, well, my mass is 44 grams as long as I only have 1 mole. So I'm going to set my number of moles as 1. And I'm going to say that, well, if I have 1 mole, my mass is going to be 44. So now to get my density, I need my volume. Well, now I've got pressure, I've got a temperature, I've got a number of moles. That's where I use the ideal gas law. So now I have N, I have temperature, I have P. I can easily find the volume and then at that point get the density. So that's what we're going to do. So we're going to plug it into the ideal gas law. So the pressure is 1. Volume is what I'm looking for. The number of moles, I've set it to be 1. My ideal gas law, constant is this. And my temperature is 273 Kelvin. So now, multiply, divide by 1. Your volume here is going to be 22.4 liters. And you might have noticed in the problem it said, okay, STP. Well, what do I know about STP? Well, I know that 1 mole is equal to 22.4. This is just another way to look at it. So I know my volume is 22.4 liters, but that's not what it's asking for. It's asking for the density. So now, one last step, take the mass of 44 and then divide it by 22.4. And that will give me 1.96 grams per liter. Okay, so let's do the opposite essentially. where we're given a density and it's asking for the molar mass. So, same thing I'm going to do. I'm going to pull out all my information. So I'm looking for molar mass. Well, what is molar mass? A molar mass is a grams to mole ratio. So I need two numbers if I want the molar mass. I need grams and I need moles, because it's grams per mole. Well, so I need these two numbers in order to get here. So let's see what I do know. Okay, I do know the density. My density is 1.16 grams per liter. I know it's at STP, so I know my pressure is 1 atmosphere. And I know my temperature should be 273. Okay, so my density. Well, density is a mass to volume ratio. So if I have that, I know for every 1.16 grams, I have 1 liter of that substance. I know this is a true statement. Okay, so I need two numbers. I need grams and I need moles. Well, if I say that I have 1.16 grams, I have 1 liter. Okay, so if I say my volume is 1, then my mass has to be this. So I can say I have 1.16 grams if I have 1 liter. So my volume will be set to 1 liter. So now I just need one other number. I need the number of moles. Well, I have pressure, I have temperature, I have volume. So I have P, V, and T, and I can solve for my number of moles here. So I'm going to use the ideal gas law. So pressure is 1. My volume is also 1. And my number of moles, I'm looking for that. This is going to be 0.0821. And my temperature is going to be 273 Kelvin. Okay, so now solve for your number of moles. So 1 times 1 is 1. 0.0821 times 273, that's going to give me 22.4. And then 1 divided by 22.4, well, that's going to give me 0.0446. Okay, so now I have got my moles. I've got mass. So now the last step is I'm just going to solve for my molar mass by dividing. So that's equal to 1.16 grams divided by my number of moles. And that will give me 26. So it's 26 grams per mole. So if I go weigh 26 grams, I have 1 mole of that substance. Okay, so does this help with that? Okay. Do you guys have any other questions about the density and molar mass stuff? Do you guys have any other questions that you want me to go over? Okay, no. Okay, so when I went into Play Pose It and I picked those dates, those are my suggested dates. That way you can take advantage of live sessions as they happen. I don't recommend trying to watch all the videos and then just take the quiz. I think you should be watching the videos as we go and then come to these live sessions and get help and then try to take the quiz. So no, nobody's going to be penalized if it says that it's late, unplay pose it. As long as you've done it before the quiz, you're fine. I just don't recommend trying to watch all of them and then take the quiz. Okay, so when I go back and look at the videos for a grade, most of the points will come from just you watching it. So you'll watch the video. I am going to allocate some of the points to be with the questions, because what I don't want happening is you to get on the video and then just go off and do something else and then not really be trying on the questions. So